In this video, we're going to look at the sum to product identities. This is really just the reverse process of applying the product to sum identities. You'll have these four properties or identities on the bottom page of your formula sheet. You'll notice that sin x plus sin y is equal to 2 times all of this multiplied together, such that we're adding the two angles together and dividing it by 2, and in this case we're subtracting it. So again, be very careful about which identity you use, making sure that you either have 2 sines added, 2 sines subtracted, or 2 cosines added, 2 cosines subtracted. And you'll also notice that we can't really condense anything if we're being adding or subtracting. If the angles are different, when we add these two things together, we now have a way to smash them together to make it a different angle on the interior based on a multiplication. So in some cases, yes, now we have a rule for adding two different angular sine functions together, but it doesn't just become the sine of x plus y, it changes the entire format of that property. So let's look at the first examples, and the first examples are going to be very much similar to the last video that we covered. It's express the sum as a product. So I'm going to have this the sine of 7x plus the sine of 3x, and then we're going to express this as a product now. So looking at my identities, we're going to look at this first identity right here where my x is now 7x and my y is now 3x, and we're going to have 2 times the sine of all this stuff times the cosine of all this stuff. In that case, we're going to have equals to 2, the sine of my x is 7x plus my y is 3x, all divided by 2, times the cosine of my 7x minus 3x, all divided by 2. If I simplify this down, I'm left with the sine of 7x plus 3x is 5x, 10x divided by 2 is 5x. And then cosine is going to be 7x minus 3x is 4x, 4x divided by 2 is going to be the cosine of 2x. And sure enough, that right there changes that addition, that sum, into a product. And now, again, if it asks us to do anything further, we might be able to manipulate this further such that we start with this one here, reducing that power of 2, or sorry, reducing the angle of 2x into something that was more singular in nature. So the last example we're going to look at in this particular video is going to be a verifying identity problem. We're going to go ahead and look at the cosine of 3x minus the cosine of x divided by the sine of 3x plus the sine of x equals to a negative tangent of x. For an identity that looks like this, our first idea, we should think about what we have at our disposal. And again, we have every single one of these identities on the page at our disposal. We could theoretically look at that cosine of 3x right there and say, well, I can tear that apart into the cosine of 2x plus 1x. And then I use this identity here with the sum and difference, and I'll notice that I'm going to have a bunch of double angles, and the double angles I can then use these things here for, and I think that's just going to get really, really heavy really fast. Is it something that I can do? Yes. Is it something that I want to do? Not really, especially if I can think of something that's more efficient. And sure enough, if I look at the sum to product identities, there is an identity for the cosine of x minus the cosine of y. There's also an identity for sine of x plus sine of y. So both of those identities there can be utilized by the sum to product identities. Now, I don't know how efficiently this is going to work out for us if I use these identities, but keep in mind that given that it's in this section, more importantly, that I have two trig functions added or subtracted together with different angles, and those angles aren't double angles, then it's more likely that I'll probably end up having to use the sum to product identities. This is also true for the product to sum identities. If I have two trig functions, sine and cosine, multiplied together, where one has, say, a 5x and the other one has a 2x, chances are I'm going to use those two, smashing them together and hoping that I'm going to get something that's workable or more feasibly workable in the result. Now, if after I attempt one of these more complicated identities, the sum to product or product to sum, and I don't get something that looks efficient for me to work with, then yes, I might drop back to the sum and difference identities in terms of manipulating the inside of a trig function so it breaks it apart. Again, I'm not sure that that's the most efficient way, but it's the ideas that we can at least attempt. So I'm going to start with my product to sum or sum to product identities. In this particular case, because I already have a sum or difference, I'm going to use the sum to product identities. I'm going to use it on this side. Given that this already has just a singular x in it, this seems like the side to work with. I need to get rid of the 3x. That's the real goal here. I need to get rid of the 3x down here as well. But for me to get rid of the 3x on top, I might have to do some real finagling in terms of the sum and difference. I'm going to avoid that. I'm just going to go straight for the sum to product identity. In this case, the sum to product identity for the top piece, again, just the top piece, is going to be a negative 2 sine of x plus y, my x is 3x, my y is 1x, all divided by 2, times the sine of x minus y, so 3x minus x, all divided by 2. That's the top. On the bottom, the sine of 3x plus the sine of x, that's going to be the first identity in the sum to product identities, and I'm going to be left with 2 times the sine of 3x plus x divided by 2 times the cosine of 3x minus x divided by 2. And again, I'm just simply matching up the 3x to my x's in that formula sheet and my single x to my y's in that formula sheet. Now you'll notice that I'm left with a negative here, so that sure enough does match up with the negative that's supposed to be there. That means that this stuff inside should just simply be sine divided by cosine, if I were to simplify this effectively. I'm not going to go ahead and deal with the 2's that they simplify out immediately. I'm also not going to deal with the sine of 3x plus x over 2 because there's one on top and there's one on bottom. They're exactly the same, so they can cancel out. So I'm just left with the sine of 3x minus x, which is 2x, divided by 2 is simply x, and therefore I get a negative sine of x over cosine of x, and sure enough, this problem is done in more or less one step. If I had done the sum and difference identities, I would then have to use the double angle identities, and I'd probably have to use more than just one step to simplify this particular identity to verify that it's an actual identity.